Hello everyone. So this is the next video. We will be dealing with inverse function theorem. What else this inverse function theorem is all about? See here we need two assumptions actually. F is a vector valued function from functions of several variables. So that means the domain is a vector valued function Rn, and here also the codomain is Rm where n and m are greater than 1. Here we say let it be a function of several variables such that f belongs to the class 1 C1 of Rn. ಏನು ಹೇಳುತ್ತಿದ್ದು C1 ಅಂತ ಹೇಳಿದ್ರೆ C1 means here you have the functions f such that f is differentiable, f dash exists and f dash is differentiable, f dash is continuous. Then we say that it is C1. What is C2? It contains set of all functions where f double dash exists and f double dash is continuous. Likewise, what is Cn? Cn contains set of all functions f such that its nth derivative exists and that derivative is nth derivative is continuous. Adanne f is continuously differentiable in the sense f is differentiable and the derivative is continuous. It contains such class. And you should have an element a in Rn such that f dash of a is non-zero. So the situation is likewise. This is Rn and this is Rm, and you have a in Rn such that f dash of a is non-zero. This is a such that f dash of a is non-zero. Then you can conclude this is the statement of the theorem. Once you have those two assumptions, then there exists an open set U. This is an open set U containing A in Rn, and you can find f of A here, and you can find an open set that contains f of A. You say that that is V, such that you can find the f inverse. You can find f inverse, that is f inverse from V to U exists. Is not saying from Rm to Rn. F inverse is from V to U, such that what is that inverse of the derivative? What is the derivative of this function? That is given by f inverse of f dash. ಅಂದರೆ ಇದ್ರದ್ದು ಎಫ್ ಇನ್ವರ್ಸ್ ಒಂದು ಫಂಕ್ಷನ್ ಆದ್ರದ್ದು ಇದ್ರದ್ದು ಡಿಫ್ರೆನ್ಸಿಯೇಷನ್ ಏನಾಗುತ್ತೆ ಅಂತ. In the sense, if f inverse is given, what will be the derivative of this? The derivative is 1 by f dash of f inverse of x. Or else you can find in this way, you take you find f inverse of x and you find the derivative of this and take the reciprocal. Idea is clear? So that is this. Now this is useful. See, for example, if this question is given, if f of x is x cube plus x, g of x is x cube minus x, find the derivative of g composition f inverse of x at x is equals to 2. See, if you find the first of all, what is g composition f inverse of x? It is g of f inverse of x at x is equals to 2 is asking. So it is g f inverse of 2. Idea is clear? So idu f inverse of 2 andre you already have f of x is x cube plus x. What is f of 1? It is 2. What is f inverse of 2? It is 1. So g of 1. Idea is clear? If you find the derivative of this, see, d by dx of g composition f inverse of x, that is equals to g dash of, you need to find the derivative of f inverse of x at x equals to 2 into differentiation of f inverse of x at x equals to 2, because you need to find the derivative of the inner function by chain rule. So already see g dash of f inverse of x. What is f inverse of x at x is equals to 2, that we need to find, and the derivative of this. This should be done. Already we calculated what is f inverse of at x is equals to 2. What is f inverse? It is 1. So g dash of 1 into d by dx of f inverse of x. What is this? G dash of 1. G of x is x cube minus x. G dash of x is 3x square minus 1. What is g dash of 1? It is 3 into 1 minus 1, it is 2. So this value is 2. But what about this d by dx of f inverse of x? For this we need to use this result. What is the derivative of f inverse of x? Derivative of f inverse of x is 1 by f dash of f inverse of x. We will use this formula. So d by dx of f inverse of x is precisely 1 by f dash of f inverse of x at x is equals to 2. Now 1 by f dash of at x, f inverse of 2 we need to find. What will be the value of this? Idea is clear? So what is f inverse of 2? It is 1. So you plug in this. But what is f of x? It is x cube plus x. What is f dash of x? 3x square plus 1. What is f dash of 1? It is 3 into 1 plus 1. So it is 4. So this value is 4. In the sense, this value is 4. So g dash of 1 already we find it, that is 2 into 1 by 4. So it is 1 by 2. The derivative of this function at x equals to 2 is 1 by 2. See, we had used implicit function theorem for this here. Idea is clear. Likewise, they will ask some questions in this. You can solve them easily if you know the inverse function theorem. We have some corollaries to it. See, if f dash of a is not equals to 0, then we say that f is invertible in some neighborhood of a. That is, it is locally invertible at that point in that neighborhood. For example, if f of x is equals to x square, where f is a function from R to R, whether it is invertible. See, this function is not 1, many one it is, right? So this function is not invertible. It is not 1, because inverse exists invertible if and only if bijection. So it is not 1 and on 2, so this function is not invertible. But whether it is locally invertible, let us assume at 3 we are checking. What is f dash of x? It is 2x. At x equals to, let us assume 1 itself. At 1 you are finding. So the value is 2, it is not equals to 0. That means it is invertible, locally invertible at this neighborhood. It is clear? Ella kada invert agalla, somewhere at some point you can restrict it and you can say it is invertible. Similarly, I can think about this example, f from r square to r square given by f of x comma y equals to x square plus y square comma x square minus y square. Is this function is locally invertible? Locally invertible means where it can be, at what neighborhood this function is invertible. See, first thing is we need to find where the derivative is going to be 0. So you find the set S such that it is a point in x comma y such that the derivative matrix f of x comma y is non-zero. That is the determinant of the derivative of this matrix. So what is the matrix for this function? It is f1x, f1y, f2x, f2y. This is your determinant of f of x comma y, derivative matrix. So this will be 2x, 2y, 2x minus 2y. If you find the determinant of this derivative matrix, see 2x minus 2y, you will get minus 4xy, again minus 4xy, so minus 8xy. This should not be not equals to 0. Minus 8 is not equals to 0. So x and y should not be 0. That means in the plane R2, if you remove this, that is the complement of this x and y axis. Apart from x and y axis, if you take any point, it is invertible, but not on this, excluding those points. For example, if you are bothered about some point, let us assume 1, 1. At 1, 1, the function is invertible. Getting my point? Or else let us assume at minus 1, 1, the function is invertible. Apart from the x and y axis, wherever you are choosing, the function is invertible. Idea is clear? Next question is, this second corollary is important. See, suppose if it is f dash of a is not equal to 0 for all a in that space, then f is local invertible. See, we are stressing here only the local invertibility, not global. That means adu f dash of a not equal to 0 ಆದ ಕ್ಷಣಕ್ಕೆ we cannot say the inverse exists for every member in that, or else if inverse exists globally, ಎಲ್ಲ ವ್ಯಾಲ್ಯೂಗೂ f inverse exists ಆಗುತ್ತೆ ಅಂತ ಹೇಳಕ್ಕೆ ಬರಲ್ಲ. The example is this. See, fi defined from r square to r square given by e power x into cos y, e power x into sin y. If we find the derivative, it is e power 2x, the determinant of the derivative matrix, and it is non-zero for all xy. But here 0, 0 also will go to 1. This is also going to 1. And 0, 2 pi, that is also going to 1. So it is many 1. Already we noticed inverse exists if and only if it is a bijection. But here it is not 1, 1. It is many 1. So that means inverse does not exist for this. But here you are getting, for every point it is locally invertible. If it is locally invertible for every point, andre in that R2, if you are considering any point in R2, the inverse exists local in any neighborhood. Neighborhood alli exist ಆಗುತ್ತೆ ಅಂತ. If it is true for every such neighborhood, you cannot conclude f inverse exists for all entries. It is only true for locally, not for all. Globally you cannot conclude. Example is this. Idea is clear? Thank you.